Type 3. Permutation of similar things. Permutation of similar things. Remember the type 1, n dissimilar things taken R at a time. Second type, type 2, n dissimilar things taken R at a time. Repetition is allowed. Okay. R is need not to be less than n. Second type. Now in this third type, type 3, we are dealing with similar things. Permutation of similar things. You remember while seeing the first type, second type and all, I told you to underline that word dissimilar. Taken R at a time. So what would be the definition of this type 3? See, taken n things taken R at a time, and in that P of them are alike. P of them are alike. The number of permutation of n things taken, not R at a time, all at a time. Taken all at a time, among them P of them are alike. Then the number of permutation it is allowed is n factorial by P factorial. Okay. Suppose more than one things are repeating. We have given n things taken all at a time. In that, some P1 number of things are repeating for some things, P1 things are alike, and P2 number of things are alike of second kind, and P3 number of things alike of third kind. Likewise, we have this one, which means more than one can be alike. In that case, what we have to do means the number of permutations is n factorial by P1 factorial, P2 factorial, P3 factorial up to Pn factorial. Okay, if you couldn't understand also, we will see the examples for this. Okay. See, in this, some things are alike. For example, take the word imagine. In this, taken all at a time, how many ways? See, taking all letters of this, how many words can be formed? So, totally how many? 7. 7. Okay. So, 7 factorial. 7 is our n. Any repeating things? I is repeating 2 times. So, 2 factorial. That's all. For this, we will take the word mathematics. Totally how many letters? 11. So 11 factorial by how many letters are repeating? M is repeating 2 times. Go by order. For this 2 factorial. P1 factorial. P1 things are alike of first kind. A is repeating 2 times. For that 2 factorial. P2 things are alike of second kind. And then T. P3 things are alike of third kind. Okay. That's all right. I not repeating. Simply. This is the total number of permutations. Any doubts in this? Then we'll jump to the questions. Also, I want you to underline something. You know what I want you to underline? See, n things all at a time, P of them alike. N things all at a time, P of them alike. Okay. Suppose instead of all at a time, we are taking r at a time. By that time, NPR by P factorial. Okay. NPR by P factorial. I'll explain you in the detail. See, we are taking all at a time. Instead of taking all at a time, suppose 5 at a time, 4 at a time means, see in this example itself, we'll take only 3 at a time if you are taking. So how many permutations can be formed? 7p3. So 7p3 by 2 factorial. That's all. Instead of this n factorial, that NPR notation we'll use. Okay. Shall I erase this? Question number 1. There are only 3 questions. Okay. Find the number of 5-digit numbers that can be formed using 2, 2, 3, 3, 4. 5-digit number we are framing. Totally how many numbers given? 5. 5 digits taken 5 at a time. So n number of things taken all at a time. So the number of permutation is 5 factorial by 2 factorial into 2 factorial. That's all. Next, look at the second question. How many numbers can be formed using all the digits 1, 2, 3, 4, 3, 2, 1 such that even digit always occupy even places? The numbers given are 1, 2, 3, 4, 3, 2, 1. So totally how many? 1, 2, 3, 4, 5, 6, 7. So we'll take 7 boxes. 1, 2, 3, 4, 5, 6. 7 boxes. Even numbers should occupy even places. What are all the even number places? Man, look at here, man. 7 boxes. This is first place. Even? No. This is second place. This is even. Likewise, fourth place. 5, sixth place. Only 3 things. How many even numbers are there? 3. So how many ways these 3 numbers can be allotted to these 3 boxes? 3 things taken 3 at a time. It is 3 factorial by 2 factorial. 2 is repeating. Is that arrangement over? No. Still these boxes are there. Odd places. So still how many boxes? 1, 2. Because this and all filled. 1, 2, 3, 4. Then remaining how many numbers? 4. 4 numbers, 4 at a time. This 4 factorial divided by perfect. That's all. These two has to be multiplied. Clear? Next, banana. Question number 3. The banana arranged so that all the A's come together. All the A's come together. Then see this all A together, we should consider it as 1. Remember? And then remaining B, N, N. So now how many things are there? 4. These 4 things taken all at time arranged. How many ways it can be arranged? 4 factorial divided by 2 factorial. That's all. Okay. Next, second subdivision. No 2 A's come together. Then this b n dash. Okay, this like we can make the arrangement. How many ways this can be arranged? This b and n can be arranged. Into how many places are there? 4. In that, how many we are filling? 3. So 4 places, 3 we are filling. The number of permutation 4p3 by 3 factorial. Okay, because 3 similar things, a only we are filling. Okay. Okay. Next, bringing. Can you try to answer that question? They begin and end with I. Yes. Think well and answer. Begin and end with I. Okay. See, listen here. See here. Wait. Begin and end with I. Okay. How many ways these 2i can be arranged? In 2 factorial ways. How many of them alike? 2 are alike. Okay. Into, still how many boxes are there? 6. 6. In that 6, how many letters are remaining? 6. 6 boxes arranging 6 things. The number of permutation is 6p6. That is 6p6 by y. See, this 2i we should not take into count. 2 factorial into 2 factorial. Okay. Understood or not? Third one. Not third one. Second subdivision. The 2 g's come together. Easy question. Okay. That's all. You didn't include that g, right? Except this g. Yes. 7 factorial by 2 factorial into 2 factorial. Perfect. Good. Shall I move to the next concept?